Guys, so I hope you did okay with the adding and subtracting fractions. Now I told you this was review work, so I'm going to plug in right away on reviewing what we've done already. This time I'm going to take us back to that same standard. It's still numbers and fractions, part 3. Only this time we're going to look at equivalent fractions and the way that we modeled those in class. So my first reminder for you is that equivalent fractions, it doesn't necessarily mean equal fractions, it's fractions with an equal value. And I'll start out with just a pretty easy basic one. If I have 1/2 and I model that with 1/2, that means one of 2 pieces are shaded in, and that represents 1/2. And an easy way to find an equivalent fraction for 1/2 is to take this and just divide it in half this way. So now instead of having 1 out of 2 pieces colored in, I have 2 out of 1, 2, 3, 4 pieces colored in. So I can see that 1/2 is equivalent to 2/4. Another way that we looked at that was with our famous tape diagrams. And we took our tape diagram, and if my whole diagram represents 1, and I'm looking at halves, that means each piece here represents 1/2. And I could take each half and split it in half, so that now I have fourths. Each one of these is now 1/4. And if I'm looking at that 1/2, I see that it's the same as 2/4. So I still have the same equivalent fractions. 1/2 is equivalent to 2/4. If I have a fraction such as 3, let's say 3/4. Remember that I can do that several different ways. So the one that we were most familiar with and most comfortable with is something like this. So I'm going to show 4 columns because I'm looking at fourths. The size of the pieces are fourths. And I'm looking at 3 of them. 3 is my numerator, so it tells me I'm looking at 3 out of 4 pieces. And right here, I'm going to show that that's 3/4. Last time we saw that I can just draw one line across. Well, I can also draw 2 lines. And if I draw 2 lines, how many pieces do I have now? I don't have fourths anymore. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm now looking at 12s. And each tiny little square is worth 1/12. So the size of the pieces are 12ths now. And instead of having 3 pieces, now if I look at the colored pieces, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of those 12 pieces are colored. So this time I can see that 3/4 is equivalent to 9/12. And it can also, here's my 3/4. I can still just do the one line. And now I see that instead of having 4 pieces, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. And instead of 3 of them being colored in, I have 1, 2, 3, 4, 5, 6. So 3/4 is also equivalent, whoops, I'm sorry. 3/4 is also equivalent to 6/8. So in this problem, I see that 3/4 is equivalent to 9/12, and 3/4 is also equivalent to 6/8. And we can see that because the same portion on both models is colored in. So each of these shows 3/4, but they also show equivalent fractions of 9/12 and 6/8. What that also means is that 9/12 is equivalent to 6/8. They are both equivalent to 3/4.